Okay. Hello. Today I am going to explain how to execute a DSP program using DSP processor. We are using TMS 3206747 DSP processor. So in order to execute a program in this processor, we require a code composer studio. It is nothing but a integrated development environment. It allows you to edit, build, debug, profile and manage a project via C programming. Okay, before executing the program, you have to set up a system in such a way we can able to run the program. So in order to set up a IDE, that is code composer studio, for a particular processor, you have to select a family, that is nothing but 6767 and platform USB emulator. Okay, once you set up a family and emulator, this configuration must be saved. So then double click on the save and quit button. If you select a yes button, then automatically the code composer studio will be pop up on your monitor. Okay, so after that you have to create a project. Under that project you are going to save a source file. Okay, in this case, before executing the actual program, the supporting files are required. Okay, in order to establish a communication between the DSP processor and the system. So the two files which are required for execution of the program for smooth interfacing of the processor and system are GEL file and the command file. So this GEL file must be added during the starting of the program, or if you want you can add it on the later on. Generally this GEL file will be stored at the desktop. So you have to select a GEL folder. So under that, if you select a GEL file, automatically the GEL file will be added to your project. After that you have to create a folder on the desktop. Here I am going to create a folder. Okay, I am create a folder like DSPP. Once I create a folder on the desktop, now I will create a project. Okay, for that you have to go to a project, then new. So for that you can give the project name as linear. Okay, linear, and then finish the project. Once you create a project with the same name, it will be displayed with the same project name, it will be displayed on the monitor. If you expand that project, it has internally so many files. It includes the libraries and it includes the configuration and so many things, that is the supporting files for execution of the program. After that you have to add the command file which will also be stored and at the desktop. Okay, so here under the file type you have to select a linker command file. Then automatically linker command file will be displayed in that file, so open that file. So that will be added to the source folder. Afterwards you have to create a file for execution of the program. Okay, so for that you have to go to file and click a new. For that you have to go to file and select a new source file. Automatically the untitled file name will be displayed on the monitor. Then afterwards you have to type the program in that file, and that file I will be stored under the name of under the file name lc.c. So here you have to type the program, that is linear convolution program, and store that file with a particular name where you have created the folder under the desktop. Okay, I have created the folder DSPPP. Okay, DSPPP. Under that I will store the program of linear convolution as a file name LC, and you have to select, okay, you have to select that LC as a C plus source files, then save it. Okay, once you have stored the program, that should be displayed with the extension of .c. Okay, here this is the program written to calculate the linear convolution of two sequences. The sequences are defined under the variable xn and hn, and output will be stored at the variable y out. Okay, this star xn star yn, it is nothing but the pointer which is used to hold the two sequences and the convoluted output. The length of the corresponding sequence will also be stored, two sequences, under xnln hnln. Okay, the two sequences are stored at the address of 100 and 200, and corresponding length of the sequences will be stored under 304. The respective output will be stored at the 400. Then afterwards you have to use the linear convolution formula. You have to, one sequence should be written as it is and another one should be folded. Then afterwards each sequence has to be moved and see the overlap. The second sequence must be sliding over until non-overlapping occurs between the two sequences. This can be achieved by using a two loop instruction is shown in this program. Okay, and all this instruction it is used to clear the memory location to store the current data. Randomly I have clear 50 memory location. That much is not required, but randomly I used 50 memory location. Okay, and once you have saved the once you have typed the this one file, after saving that, this file, source file, must be added to the folder where you have created originally and at the desktop. So that can be done by right clicking on the source, then select add files to project. You have to store originally where you have created the folder, that is folder name is DSPP. Okay, then select lc.c. So automatically that source file will be added to your original folder, and after that you have to check whether the program is error free, or you have to debug the program. So for that you have to go to project, then rebuild all. So if the program is error free, then message will be displayed with 0 errors and 0 warnings. And after that, once the program is error free, you have to dump the program from the system to the DSP processor through the USB port to JTAG using a JTAG. That can be achieved by selecting a toolbar, debug, and then connect. Once you select a debug and connect, the DSP processor or the system will communicate with the DSP processor through the USB cable. It takes some time, until that you have to wait with the patience. So here in the disassembly window, now after once the target is connected, the disassembly window will be appear. Okay, you have to wait for some time in order to establish a proper communication between the processor and the system. And then afterwards you have to load the program from system. Once the connection has been established from the system to processor, you have to load the program that can to the processor. That can be done by using a file load a program. So you have to go to debug, then you have to go to your original folder DSSP, then what is the linear, in that you will have a folder debug, then linear out. Okay, once you select that, we are going to dump the program from the processor, from the system to processor. And after that, once the program has been successfully dumped from the system to processor, you have to go to the view toolbar and you have to load the data through the memory. So initially I have assign the address to load the data. This memory location, you have to enter that 100 memory location. The data type I have declared as integer, so 32 bits signed integer. Then move the cursor to at memory location, then press enter. So automatically it will display the number, the data whichever you want to give, and enter the data. 1, next 2, next 1, next 1. Okay, the first data I have taken is length equal to 4 with the sequence of 1 2 1 1. So I have given 1 2 1 1. The second data will be stored at the memory location 200 with 1 1 1. So the second data will be stored at the memory location 200. Okay, so enter that memory location, then store the data, that is 1 1 and 1, that is the sequence length is 3 with the data I have taken is 1 1 1. Next, at xn ln and hn ln, that is memory location I have taken is 300 and 304. So 300 and 304. In 300 I have stored length is 4. In 304 I have stored memory location, the sequence length is 3, and afterwards you have to press enter. This number should be displayed, whatever last value should be in the red color, then only the processor will register that data, otherwise it won't take the data that you have entered by using a keyboard. Once the data has been entered, you have to press enter. Then afterwards, where the result is storing at the 400, so enter 400. Then afterwards you have to execute the program. For that you have to go to debug under toolbar, then click run. So the program will be executed. The convoluted output is nothing but 1 3 4 4 2 1. So the convoluted output is 1 3 4 4 2 1. Okay, the convoluted output will be obtained. This is the end of the first hardware program, nothing but linear convolution. Okay, thank you.